Hello students, in this video we are going to discuss short procedure and Viva-Voce question for the titration, conductometric titration. So under this we have two titration. The first one is strong acid versus strong base and the second one is a mixture of acid versus strong base. So let us see the conductometric titration of strong acid versus strong base. And the short procedure for this burette solution is standard NaOH and the pipette solution is unknown HCl, and the endpoint you'll be having decrease in conductance and increase in conductance. The decrease to increase will be called as your endpoint, right? The equivalent weight of HCl is 36.5 and the electrode we use is conductivity cell. And you should draw the model graph, and in this model graph we'll be taking volume of NaOH in x-axis and conductance in y-axis. So initially you will be having decrease and after particular point you will be having increase. So the decrease to increase, this particular point will be called as your end point. Now let us see the second titration short procedure, that's conductometric titration for mixture of acid versus strong base. In this the burette solution will be the same, that is standard sodium hydroxide, and the pipette solution will be the mixture of acid. So in this mixture, one acid will be the strong acid, the other one will be the weak acid. So both the acid will be mixed together and it is given as a single solution, that is mixture of acid. The example for strong acid will be HCl and for weak acid it's acetic acid, right? The endpoint here you could find two endpoints here. Initially you have decrease in conductance till particular point A, and after that you could find slight increase up to the point B, and after B you have sudden increase in conductance. So that's what we say the endpoint is decrease, slight increase and sudden increase in conductance. And equivalent weight of HCl is 36.5, equivalent weight of acetic acid is 60, and the electrode we use is the conductivity cell. And this is the model graph for mixture of acid. So we'll take volume of NaOH in x-axis and conductance in y-axis. This graph is very important because this short procedure, the 6-point and this model graph includes the particular titration. So next we'll discuss the Viva-Voce question. The first question is, what is conductance? Write its SI unit. The answer is, the current conducting ability of material will be called as conductance and its SI unit is Siemens. Next question, give example for strong acid and strong base, and along this I have added weak acid also because in this we have seen mixture of acid. So the examples for strong acid are nitric acid, HNO3, HCl, that is hydrochloric acid, then sulfuric acid, its formula H2SO4. Now let us see some examples of strong base like sodium hydroxide, it is NaOH, potassium hydroxide is KOH, calcium hydroxide, it's CaOH twice, magnesium hydroxide, it's MgOH twice. And the best example for weak acid is acetic acid and its formula is CH3COOH. Good. Next, third question. Explain why hydrochloric acid is a strong acid. So the reason is HCl is 100% dissociated in all concentration. Hence, it is regarded as strong acid. Once you dissolve HCl, it gets dissociated to H plus ion and Cl minus ion. See here, HCl on dissociation gives H plus Cl minus. This equation is very important, right? Next, what is meant by strong base? So any base which have the ability to dissociate 100% is called a strong base. And in equation, we have to represent it as NaOH on dissociation gives Na plus OH minus ions. Next question, give reason for the decrease of conductance of an acid when a base is added initially to it. This is the principle. So the answer for this question is, at the beginning of the titration, you could find the conductance of acid is very high and that is mainly due to H plus ions. But when you add the base, the fast moving H plus ions will be replaced by the slow moving Na plus ions that is added from the burette. Hence, you will be having decrease in conductance, right? Next, why the conductance increases when a base is added after the endpoint? So after the endpoint, so as I told you, initially you will be having decrease, and after a particular point you will be having increase. The reason for the increase is, so after the endpoint, the further addition of base due to OH minus ion results in the increase in conductance. So this is mainly due to a strong base, especially OH minus ions. This is 100% dissociated, and there is no strong acid that is present further to neutralize the base. Yes. The next question, write the formula that is used to calculate the amount of HCl. So whenever we calculate the amount, the formula we use is equivalent weight into normality. So equivalent weight means it is equivalent weight of HCl, 36.5. Next question, write the equivalent weight of HCl and acetic acid. As I told you, equivalent weight of HCl is 36.5, and you should know the equivalent weight of acetic acid, that is 60. The last question, why the conductance increases linearly after the first endpoint? And this question corresponds to mixture of acids. Okay, so the answer for this question is, the first endpoint corresponds to the neutralization of strong acid by strong base. This is similar to the strong acid versus strong base titration, but we should give importance to the next endpoint. So that is after the first endpoint, the added base begins to neutralize the weak acid, that is acetic acid. So this acid is feebly ionized, and less amount of H plus ions are available to OH minus ions for further neutralization. So the conductance increases linearly. So this is the reason why there will be increase linearly after the first endpoint. Hope you have understood the Viva-Voce and short procedure. Thank you.